We're going to solve several systems of equations with elimination. In this first example, you'll notice that our y's have the same coefficient, but negative signs. One's -1 and one is +1, which means that we are ready to add these two together. So I'm going to go ahead and add these two together, doing like terms as I go. So I end up with -4x minus 5x, that's going to be -9x. I'm eliminating the y's, and that's because they've got those opposite coefficients, so the y's have been eliminated. On the other side, I've got 6 and 21, which add to 27. So now I've just got to divide by that -9, and I get my x value. X is equal to -3. But as I'm solving, I'm looking for a point. So my answer is going to be an x comma y. Right now, I only have the x, so I need to go back up to either of my equations and solve for the y. It really doesn't matter which one. So let's go ahead and take this first one here. So I've got -4x plus y is equal to 6. Well, I do have a value for x, so -4 times -3 plus y is equal to 6. This is 12 right here, so I've got a +12. I can subtract the 12 from both sides, and I end up with y is equal to 6 minus 12, or -6. So I've got -3, -6 for my answer. In this next one, I can't just eliminate one of my variables as is. Instead, I need to build up those opposite coefficients. So I'm going to choose one of my variables. I want the same number out in front, but opposite signs. Take a look at these y's. They are actually really close. They already have an opposite sign. One's positive, one's negative. All I need to do is to multiply this first equation by an 8, and that's going to give me an 8y here. Let's go ahead and do that and rewrite our system. So I am multiplying the entire first equation, every single term, by 8. So I end up with -5 times 8, that's going to be -40x. 8 times y is going to be plus 8y, and then -3 times 8 is -24. I can just bring the second equation over, no changes there. So I get a 3x minus an 8y is equal to 24. As I add these together, so I'm ready to add them together now, like terms, I get a -37 for x, so -37x. The y's eliminate, which is perfect. And on the other side, I end up with equals 0. I can divide both sides by -37, although I don't really need to, because the only way I can make this equal 0 is if x is equal to 0. Now remember, that's only half of my answer. My answer is going to be a point, and I need it to be an x comma y. Right now I've got 0. I need to go and find my y. So as I'm looking for my y, you can take either of your equations. We're going to call this step number 1 over here. Let's call this step number 2, finding our second variable. I'm going to go ahead and grab that first equation. Doesn't matter which one, but I think the first equation is just a tiny bit simpler when it comes to finding y. Let's see, I've got my x, so -5 times 0, that makes it super nice, plus y is equal to -3. That one goes away, and y is equal to -3, so our solution is 0, -3. In this one, I again need to choose a variable to eliminate. Honestly, you could pick either one. I'm going to go ahead and choose the x's. So if I choose the x's, that means that I need a -2 right here. So I need to multiply this entire second equation by a -2, and I can go ahead and just carry the first equation over. So the first equation, just rewriting it, 2x minus 3y is equal to -1. Now let's multiply everything in this second equation by -2. So I get a -2x. -2 times -y is plus 2y. -2 times 1 is -2. I am ready to add these together, so I'm going to go ahead and combine those like terms. The 2's cancel, which is perfect. And then as I continue here, -3y plus 2y, that's going to be a -1y. And then -1 minus 2 is a -3. Just need to swap those signs. I'll divide by a -1 and y is equal to 3. I'm almost to my solution, but I've just got the 3. So step number 1 is done. Step number 2, let's go ahead and find the other variable. I need to figure out what x is. Notice that x is already by itself in the second equation. There's no number multiplied. So I'm going to use that second equation. X minus y equals 1. So y was 3, x minus 3 equals 1. Add a 3 to both sides, and x is equal to 4. I can pop that into my solution, and I end up with my solution of 4, 3. Now in this one, I don't have everything all lined up, so that's going to be my first task. I want to make sure that all of my x's are in line, y's, and the numbers. So I'm just going to go ahead and scooch some things over, and I'm going to add the 9y to both sides. So my system's going to now look like this. 2x plus 3y is equal to 7. I'm going to move the 6x so it's in line with the other x term. I added a 9y to both sides, so I get a plus 9y here. And then the 11 is going to go ahead and stay where it was, so equals 11. Now I can eliminate either one of my variables here. I'm going to go ahead and choose to eliminate the x's. It's actually going to turn out to be the same value that we multiply by. I've got a 6 in the second x, so that first coefficient, I really need to make that guy a -6. So I need to multiply everything by a -3. So this entire first equation is going to get multiplied by a -3, but I can bring that other equation over as is. So here we go. If I multiply everything by a -3, I get a -6x. -3 times 3y is minus 9y. And then I get equals -21, so equals -21. Bringing the second one over, I get 6x plus 9y is equal to 11. Well, look what happens. Not only do my x's eliminate, but my y's eliminate also. So I get 0 on the left-hand side. On the right-hand side, I get -21 plus 11, which happens to be 10, but it really doesn't matter because 0 is not equal to 10. That means that this statement that I'm getting here is false. I was looking to see if these two equations intersected their lines, but because it's false, it means that these two do not intersect. There is no solution. So you could write the little empty set symbol there, or you could write out no solution. So in this one, there's not an obvious choice here for which one to choose to eliminate. Remember, we're trying to get those terms to be opposite. So it really doesn't matter which one you choose. I think I'm going to choose the x's. If you were to choose to eliminate the y's, you would get the same thing. 7 and 2, they both divide into 14. So my goal is going to be a 14 for the x, and let's do a -14 for the second x. So I'm going to keep track of what I'm multiplying by. For that first equation, to get from -2 to 14, I need to multiply by a -7. For the second equation, to get from a -7 to a -14, I'm going to multiply by 2. Let's start by multiplying the first equation by -7. -7 times -2x is 14x. -7 times 6 is -42, and that was the y. And then I'm multiplying by 6 again, so that's going to be another -42. Now on to our second equation. Multiplying everybody by 2, I get -14x. 2 times the 8 is going to be plus 16y. 2 times the -5 is -10. I am ready to add these together. So combining those like terms, the x's cancel, which is great. -42 plus 16, you can always use your calculator for that. You end up with a -26y. And then -42 minus 10 is equal to -52. Let's divide everybody by that -26. So I end up with y is equal to 26 goes in there twice, and I get 2. Okay, so my solution has a 2 here. So step number 1 is done. I found one variable. Step number 2, let's go ahead and go back and find the second variable. I need to find x. You can choose either equation, it doesn't matter. I think I'm just going to pick the first one. So I've got negative 2x plus 6, y equals 6. Y was equal to 2, so I can put a 2 there. So I get negative 2x plus 12 equals 6. Subtract the 12. Negative 2x is equal to negative 6. Divide everybody by a negative 2, and we get 3. So x is equal to 3, and there is our solution. Now I'm trying to give you a really good variety, and I think I've got just one more type to give you so that you are completely prepared for these. Here comes the next one. So in this one, the very first thing I've got to do is to line up those variables. So I want all of my x's together, so let's subtract a 2x from both sides. And I think everything else can stay where it is. So I get my first equation, x minus 5y is equal to 2. In my second equation, I get negative 2x plus 10y is equal to negative 4. Now this is an easy one to decide how to eliminate. Let's go ahead and choose those x's, and I'm going to multiply everything by a 2 in the first equation. So in that first equation, I end up with 2x minus 10y is equal to 4. I'm just going to bring that second equation over and look what happens. I get negative 2x plus 10y is equal to negative 4. This time when I add things together, everything eliminates. Everything eliminates. I get 0 is equal to 0. That means no matter what I put into this equation, no matter what xy pairs, it's going to make this one true. So this is true for all of the xy pairs in both of these lines. Here's what your answer looks like though. These are 2 lines. It means that these 2 lines, I don't know exactly what they look like, but they line up everywhere. Oops, they're supposed to be exactly the same line. I'll make that really thick. Okay, so it means that they're the same line. How do you express that in an answer? Well, my answer are points, right? So in this case, I can't just give a single point. So I'm going to give a set of points. So it's the set of all of the xy's that live on my line. So all the xy's that live on my line is defined by either equation. It doesn't matter which equation you put in here. I'm just going to grab the first one, x minus 5y equals 2. So my answer is the set of points, since it's not just one, but I wanted to make sure that it wasn't just any old point. It was a point on and either equation can go here. You're going to get these. I have a feeling that you're doing great already so far. Take a look at this next video, and thanks so much for watching.